Welcome to this video, which is about studying the role of production evaluation and product evaluation for the acceptance of CO2-based fuels using a method called PLS-SEM. My name is Linda Engelmann and I work at the Chair of Communication Science at RWTH Aachen University. This video is part of a 3-video series recorded for the eCOCO2 project, a Horizon 2020 project that focuses on the direct electrocatalytic conversion of CO2 into chemical energy carriers. Before we get started, let me show you the contents of this video. First of all, I'm going to talk about the research question that we will investigate in this video, which is, are evaluations of production and of products connected? Second, I'm going to show you how evaluations can be measured as something that is called a latent construct in the social sciences. After that, we'll have a look at the method that can be used for answering our research question, which is structural equation modeling. Once we've looked at the method, I'm going to present to you first the hypothesized model and secondly the final model that could be built to investigate the relationship between production and product evaluation and their impact on acceptance. Lastly, we'll summarize what we've learned. Let us start at the beginning with our research question. In this video, we are asking ourselves, are evaluations of production and evaluations of products connected? In the second video of this series, I have already talked about factors that can have an impact on whether a person accepts a product or technology or not. This can be, for example, advantages or benefits, disadvantages or barriers, or risk perceptions. In case of the carbon capture and utilization technology, previous research could show that for both the CCU technology as a climate change mitigating approach and for manufactured CO2-based end products, there are benefits and barriers that are perceived by lay people. What has to our best knowledge not been studied is whether there is a connection between how people perceive the technological production and how they perceive the end product, which is in our case CO2-based jet fuel. This is interesting for us to study in more detail, for example, to check if in any case a person perceives mainly barriers regarding production, if this will cause them to also rather dislike the end product, or if these two are rather isolated topics. To study this, we used a survey with 2,187 people. The results, part of which I'm going to present to you now, have been published in the article that is referenced on this slide, if you'd like to take a look at it. I've already talked about so-called perceived benefits and barriers that people may take into consideration for their decision to accept or use a technology or product. But how is it possible to actually measure these evaluations or so-called latent constructs? A concept like acceptance or people's evaluation of an object like a technology are not directly measurable, like for example physical quantities like temperature or weight. We call these concepts latent constructs that are measured by multiple items or statements, for example in an online survey, as is presented on this slide. In case of affective and cognitive evaluations, participants are presented with a list of these items and indicate their agreement. Afterwards, their answers are combined into latent constructs by calculating the mean value of the agreement. For our research question, this was done for several different topics. We asked people about their affective and cognitive evaluation for the CCU approach and its utilization to produce CO2-based products, the end product, CO2-based fuel, and for their support and willingness to use CO2-based fuel, that means for their acceptance. Once people took part in the survey, we are then able to combine their answers into latent constructs that can be included in models and further analysis. One method for which the concept of latent constructs is relevant is structural equation modeling. In this study, we used partial least square structural equation modeling, or PLS-SEM, to estimate the relationships between the different constructs. A model designed using PLS-SEM consists of two model layers that are analyzed simultaneously. The first is the measurement model, or outer model, depicted in green on this slide. The relationships between the included constructs and their indicators are referred to as the measurement model. The second is the blue-colored structural model or inner model, which consists of the relationships between the different constructs. In the present study, the structural model was used to evaluate the hypothesized relationships between constructs. Based on previous research, we were able to hypothesize several relationships between the included latent constructs. Some of them relate to cognitive evaluations. Hypothesis H1A, for example, was used to check if there is a positive influence by cognitive benefit perceptions on the acceptance of CO2-based fuels. For example, we hypothesized that a person who believes that the use of CO2-based fuels in aviation holds advantages, for example for the climate, will more likely accept the use of CO2-based fuels in aviation. Others focused on the influence of affective evaluations. Here, for example, we hypothesized that people who have a positive affective evaluation of CCU as the underlying technical approach will also have a positive affective evaluation towards the final product, CO2-based fuel. Based on previous research, there were a handful of these hypotheses that we combined into a hypothesized model for the perception and acceptance of CCU production and CO2-based fuels. This figure shows all the hypothesized relationships that we assumed before checking the actual relationships between the constructs. Some of them relate to CCU, while the right part is about the perception and acceptance of the end product, CO2-based fuels. The different lines between the constructs indicate different types of relationships. Thick solid lines, for example, indicate a link between perception and acceptance of the end product, while the dotted lines indicate all hypothesized relationships between the perception of CCU and the perception of the fuel. We then included all the items that we used in the survey and the hypothesized model and used PLS-SEM to estimate the relationships between the constructs. Let's have a look at the results. I know this might look a bit confusing at first glance, but we will go through it step by step. The gray boxes at the upper and lower bound are the subconstructs that form some of the main constructs. For example, barriers of CCU was formed using two subconstructs, namely perceived policy barriers and sustainability barriers. The oval constructs in the middle are the latent constructs for which we assumed relationships. Let's have a look at which links actually could be identified between them. For the end concept on the right, which is acceptance of CO2-based fuel, there are several direct relationships with other constructs. First of all, perceived benefits of the product, as well as perceived benefits of CCU as the underlying technological approach, directly influence acceptance. The beta values, next to the arrows, refer to the strength of the relationship. It is to be interpreted as follows. If the construct on the left changes by x, the construct on the right changes by x times beta. For example, if the benefit perception of CO2-based fuels changes by 1, then acceptance increases by 0.45 scale points. When we compare the influence of the two green-colored constructs, we see that the influence of perceived benefits of the end product is larger than the one of benefit perceptions of CCU. Additionally, there are negatively impacting constructs. Barrier perceptions of the end product, such as perceived safety risks, have a negative influence on fuel acceptance. If barrier perceptions increase by 1, acceptance is estimated to decrease by 0.21. There are also direct links between the cognitive evaluation constructs. That means the more a person perceives CCU to be beneficial, the more they perceive the manufactured fuel to be beneficial. Correspondingly, the more they think that CCU poses barriers, the more they are likely to also perceive the end product to be disadvantageous. Apart from links between cognitive evaluations, there is also an impact on acceptance of CO2-based fuels by affective evaluations. Additionally, affective evaluation impacts people's barriers and benefit perceptions for the fuel. The more positively people feel towards CO2-based fuels, the less they will think of them to be disadvantageous and the more they will perceive them to be beneficial. This direct link also means that there are indirect links. Through its influence on barriers and benefits, affective evaluation has both direct and indirect impacts on participants' acceptance of CO2-based jet fuel. If we move further down the model, or to the left, it is evident that there are more links between the perception of CCU and the fuel. Using PLS-SEM, we were able to estimate the relationship between people's effective evaluation of CCU as the technological approach and their cognitive evaluation in form of benefit and barrier perceptions. The more they feel positively towards CCU as a technology to capture CO2 and use it for manufacturing of goods, the less they think that CCU is disadvantageous and the more they perceive them to be beneficial. This also holds vice versa. Finally, there is also a link between the two effective constructs of the model. The more people feel positively towards CCU, the more they have a positive effective evaluation of the manufactured CO2-based jet fuel. The beta value for these relationships indicate a very strong influence between the two constructs. So let's sum this up. What this complex model tells us is, yes, the perception of CCU production does influence the perception and acceptance of the product CO2-based jet fuel. As the estimated model shows, there are impacts on the acceptance of CO2-based fuels by both affective and cognitive evaluations. These connections additionally have both direct and indirect effects. For example, there was a direct influence of benefit perceptions of the technology on the acceptance of the product. In other cases, there were indirect links, for example, for the barrier perception of CCU, which influenced the barrier perception of the fuel that ultimately impacted acceptance. This brings us to the end of our video. Here you see the used references from this video. Thank you for watching this video. You can find more information on the project on our website or on social media on Twitter, LinkedIn and YouTube. Thank you and have a nice day.